Hi everyone. In this video, we are going to derive the quadratic formula from the general form of quadratic equation. So you know that the general form of quadratic equation is like this: ax squared plus bx plus c equals 0. Now looking at this, looking at the left hand side of this equation, the quadratic expression that we have, we really cannot factorize this expression easily. So to solve a quadratic equation, factorization, though factorization is one of the ways, but in this case we really cannot easily factorize this expression. So we have to take some other approach, and let's see how this works out, right? So from here, what I'm going to do, well, another thing I should mention up front, that for a quadratic equation, the coefficient of the leading term, which is that a, the coefficient of the leading term, that a cannot be 0, because if a becomes 0, then the leading term will disappear. That means it will not be a quadratic equation anymore. It will become a linear equation, right? So the necessary condition here is that a cannot be 0. Alright, now let's try to proceed. So from here we can say that if we divide both sides of the equation by a, then each of the terms on the left hand side will be divided by a, and similarly on the right hand side also 0 will be divided by a. And since a is not equal to 0, dividing by a would be fine. There is no violation of any mathematical law here, right? So if we divide both sides by a, this is going to look like this. So it will be ax squared divided by a. Each of the terms will be divided by a. Similarly bx divided by a. Similarly c divided by a is equal to 0 divided by a. Let me also say 0 divided by a. From here we can say, okay, so a and a cancels out each other because they both are in the numerator and denominator. So from here we get x squared plus b by a times x plus c by a is equal to 0 divided by anything is 0, right? Then from here we can say, okay, so if we try to rearrange, or if you try to somehow come up with a whole square of x plus something, right? That's what I'm trying to do here. So let's see. We have an x squared term, then we have an x term. So somehow if we can convert this into a 2 times x times something, right? 2 times x times something, and that something has to be such a number so that this second term will become equal to the existing second term there, right? Our original second term is b by a times x, and similarly here also we need to ultimately we need to have b by a times x, but we are trying to write it in such a way that it looks slightly different, but ultimately it will be b by a times x. So if I simply say b divided by 2a, if I say b divided by 2a, now you see the b by a is fine. The 2 in the denominator and the 2 up here will cancel out each other, and x is also there. So ultimately this is same as b by a times x, right? And then we if we had one other term, something like this, if we had one other term, say suppose b by 2a whole squared. If we had a term like that, I know we don't have that term, but if we had a term like that, then you can see this entire thing become a whole square. It becomes x plus b by 2a whole square, right? So what I'm going to do, I'm forcefully introducing this term. I'm forcefully introducing this term, and now I'm going to subtract this term also, so that the expression here doesn't get out of balance, meaning whatever I forcefully added, I subtract the same quantity, which is b by 2a whole square, right? So I added it, then I subtracted it. That means as if nothing happened, right? Plus I also have the c by a, which we cannot miss. So all of this equals to 0. Alright, so from here we can say, okay, now let's do this whole square. So now the first 3 terms is going to give us x plus b by 2a whole square, and then we have minus, let's remove this parenthesis. So it will be b squared by 4a squared and plus c by a is equal to 0, right? So from here we can say, okay, now x plus b by 2a whole square minus, let's try to enclose them within a parenthesis, right? Let's see what happens. So it will be b squared by 4a square, I'm sorry, b square by 4a square, and minus c by a. We have to change the sign because there is a negative sign outside of the parenthesis, so the positive c by a becomes negative c by a, and this is equal to 0. Let me scroll down a little bit, and then from here we can say, okay, x plus b by 2a as is, no change here, x plus b by 2a whole square minus, let's try to simplify this. So what is our LCM? Our LCM is 4a squared. So for the first term, the LCM and the denominator, they are same, so it will be just b squared, and then minus, here the denominator is a, but the LCM is 4a squared, so it will be 4a times c, so it will be 4ac, right? That is equal to 0. So from here we can say, okay, x plus b by 2a whole square minus, now I want to write this thing as a whole square, right? Then what will happen, you see we already have one square right here, it is a square minus another square, so the difference of two squares will give us an opportunity to factorize them easily, right? So now I'm going to write it as a whole square. So what I need to do, well, I need to put them under a square root, then the whole square and the square root, they will cancel out each other, so ultimately our value will not change, right? So here if we say b squared minus 4ac divided by 4a squared, right, that is equal to 0. Hence we can say, okay, our x plus b by 2a whole squared minus, let's try to simplify a little more right here. You see the 4a squared, it's a perfect square, it's actually 2a whole square, right? So in the denominator I'm going to get rid of the square root for the denominator, and I'm going to write it as 2a, because the square root of 4a squared is 2a, and then in the numerator I'm going to continue to keep the square root, which will be under the root, it will be b squared minus 4ac and whole square of this, right? That is equal to 0. So now let's scroll down a little more and let's try to simplify further. So from here we can say, okay, now we can clearly see that it's a difference of two squares, because this is, if you simply imagine this as a maybe and this as b, so it looks like a squared minus b squared, and we all know that a squared minus b squared, it factors out to a plus b times a minus b, and we are going to now use this technique to factorize the left hand side of our equation. So now, so from here we can say, okay, so this is actually equal to, oops, let me continue with the same color. So this is actually equal to x plus b by 2a plus this second quantity here, which is 2a here, and then b square minus 4ac, right? And then times, we have x plus b by 2a minus the second term, which is again 2a here, and then root over b square minus 4ac, and this product is equal to 0. That's our original equation. So from here we can say that x plus, let's combine these two other terms together, right? They both have the same LCM there, 2a, same denominator, so the LCM will be 2a, so it will be 2a, and we can say, okay, this is positive b, and then plus root over b square minus 4ac times, we have x plus Here again, if we combine them together, they will be b minus root over b square minus 4ac, and this product is equal to 0. Now you see, we have two factors and their product is equal to 0. That means either one of them could be 0, meaning the first one could be 0 or the second one could be 0. So essentially from here we can find the value of x for which this equation will satisfy, right? So from here we can say, okay, then either the first term is 0 or the first factor is 0, which is, we can say like this, x plus b plus square root of b square minus 4ac whole upon 2a. Either this term is equal to 0 or our other term, which is x plus b minus square root of b square minus 4ac whole divided by 2a equal to 0. So from here we can say that x is equal to, now let's look at this first little equation. Now we are looking at like two little equations here, right? So from the first one we can say, okay, x is equal to, now the b will become negative and the square root term will also become negative. All of them will become negative. So it will be negative b and then negative square root of b square minus 4ac whole divided by 2a. Or, because you see what we did, we transposed it to the other side. So we kept the x on the left hand side and we transposed the other term to the right hand side. So now x is equal to negative b and then minus square root of b square minus 4ac whole divided by 2a. Or here again we keep the x on the left hand side and bring everything to the right hand side. Then this thing will become negative of this. So that means the positive b will become negative b and the negative square root term will become positive and whole divided by 2a, right? So here we see the two possible values of x. One is negative b minus square root of b square minus 4ac by 2a. Another one is negative b plus square root of b square minus 4ac by 2a. So these are the two possible solutions of the quadratic equation that we started with, and they will be called the roots of the equation. So these are actually called the roots of our equation. So those are the two possible roots. And sometimes, people might indicate it like this, x sub 1 and x sub 2 to indicate that the first value is one of the roots and the second value is the other root. And because we are working with a quadratic equation, there will be two roots. Because the highest power of x in a quadratic equation is 2, so the number of solutions will also be 2. So these are the two solutions which should satisfy our original equation. And now if you want to write a combined picture of this solution, then maybe we can write it like this: x is equal to, now you see there is only one difference between these two values. There is only one difference right here. Sometimes this is negative. For one solution that is negative and for the other solution it is positive. Otherwise everything else is exactly same, right? So we can say, okay, x equals, let's say 2a right here. Then here I can say negative b, both the cases it is negative b. But then for the square root term, let me first write it down. First I am going to write the square root term, which is b square minus 4ac. And here sometimes we could have a plus or minus, right? So for the two possible values, it's either plus or minus. And this is called the quadratic formula. Then minus b plus minus root over b square minus 4ac divided by 2a. This is called the quadratic formula. I hope it all made sense. Thank you for watching. See you in the next video.